So this video is going to look at 8D on creating rules for the nth term in a sequence modeling linear growth or decay. It's going to build on the 8C stuff. So if we've got a recurrence relation in the form of Vn plus 1 equals Vn plus D, remember this was our linear growth, or in Vn plus 1 equals Vn minus D, which is decay, those rules allow us to calculate any term in a sequence directly. But that can be really laborious if we're trying to find, say, the 50th term, because we'd have to calculate all 59 before it, which takes a bit of time. So instead, we can actually remodel the equations to find Vn in terms of Vo. And so what this does here is we can say that Vn, so any term, is equal to the principal plus n times d. So n lots of that simple interest that was adding on for linear growth, or n lots subtracted of the amount being decayed there. So if we look at simple interest, I just said recall that initial formula that we had. So VO is principal, and then Vn plus 1 equals Vn plus D. We can rewrite this, like I just said, to say that Vn is the principal plus n times D. And in this case, n is the number of times that you're adding on that interest amount, and D is still calculated in the same way, being R over 100. So if we look at a problem involving this, we've got here a recurrence relation, and it's got VO equals 5,000, and then Vn plus 1 equals Vn plus 150. So first of all, it wants us to say what is the principal of the investment, and that's our VO amount. So it means that the initial investment was worth $5,000. It says how much interest is earned on the investment each year. That's that D amount that we're constantly adding on. So each year we're adding on $150. And the question here wants us to work out the interest rate. Now, we can be a bit clever here because it's wanting to work out that D value. So we're saying $150 equals R over 100 times 5,000. Now, I can rearrange that, or I can just hop onto my calculator and use the solve function. So in solve, I'm going to press 150 equals, and then I'll put in x over 100 times 5,000, comma x, close my bracket and enter, and it's telling me x equals 3. So this means that my interest rate is then 3% per annum. D, it wants us to write down the rule for the investment after n years. So what we're doing now is we're writing this Vn rule. And remember, it is the initial amount, so $5,000 plus n times the amount that's added on is 150. Now, that looks a bit icky. It's a bit nicer for us to actually write this as 5,000 plus 150 n, okay? So that's our rule now in terms of n, and this means that we can use the rule to find the value of investment at any time, but for E it wants us to find it after 5 years. So if I put here V5 equals 5,000 plus 150 times 5, and again, back to my calculator over here, 5,000 plus 150 times 5, and that gives me 5,750. So hopefully you can see here with this rule, it's been much quicker for me to find the answer rather than having to add on 155 times. The same process happens with depreciation, and just depending if we've got flat rate or unit cost depreciation. So recall these are our previous rules, but for flat rate of depreciation, it's going to become VO, so the principal minus n times that depreciation, so the number of years times whatever the depreciated amount is, which we still find using that same formula as before. And for unit cost depreciation, it's actually the exact same rule, but remember this time we know is D, the cost per unit of use. So I've got two problems for us to look at for these ones. I'm just going to enter this down to a new page for us. It says that the following recurrence relation can be used to model the flat rate depreciation of a new car. So this is actually the rule from the example that we did in the last video. And so it says, what's the initial value of the car? Remember, that's the VO. So the car was initially worth here $40,000. And how much does the car decrease in value each year? Well, each year we are subtracting $6,000, so it's losing $6,000 in value. Now it says write down the rule for the car after n years. So remember, now we want our rule to start with Vn. It's going to be VO, because we've got this initial amount, minus 6,000 times n, because we're losing $6,000 each year, so each n. And finally, it wants us to know how much the car is worth after 4 years. So V4 equals $40,000 minus 6,000 times 4. Sorry, in this original rule when I wrote it, I'm going to rub that out. I should have written in here 40,000, because I knew that that VO value was 40,000, so I could just substitute that value in. 40,000 minus 6,000 times 4, so I can pop that in here, or I could work that out in my head, but my calculator will do the work for me, and I get then that after 4 years the car is worth $16,000. My final question here for 8D, everyone, it says that a school bus is purchased for $200,000 and it depreciates at a rate of 40 cents per kilometre travelled. Model the depreciating value of the bus using a recurrence relation. So in this case, my VO is at $2,000 and my D value is 0.4, because for every single kilometre it is 0.4 that's being removed. So the depreciating value, so Vn, equals $200,000, because that's how much we bought the bus for, minus 0.40 n. And remember, n in this case is each kilometre that it's travelling. Now, well, that says C, but let's just say it's A and B. Determine the value of the bus after 4 years if it travels on average 60,000 kilometres per year. Now, I need to know how many kilometres in total that is. So total kilometres then is going to be 4 times 60,000. Oh, too many zeros. Times 60,000, not 600,000. And that is 240,000 kilometres. So now what I'm trying to find is VO of 240,000 kilometres. You can imagine that would be really, really annoying for us to count in our calculator that many times, but I can substitute that straight into the rule and then I can enter it in here. So 200,000 minus 0.4 times 240,000, and then it tells me that the value of the bus is $104,000. So over those 4 years, the bus has lost $96,000 in value. So that there is a summary of 8D. Hopefully you can see how 8C and 8D are connected, and it allows us to rearrange the rule so that it's just in terms of the nth term, so I can use the rule to find any value straight away rather than having to find each value and add each time like we were doing in 8C. Thanks guys.